All right, it says 2 o'clock on my computer screen here, so we'll go ahead and get started. Thanks everyone for joining us today. My name is Noah Newman. I'm a technology editor with Strip-Till Farmer, and welcome to this Strip-Till Farmer webinar with DigiFarm, making sense of the different types of RTK technology. Steve Riddle of DigiFarm is our presenter today. He has 35 years of experience in precision ag, helping strip tillers understand the various types of RTK and setting expectations for expected accuracy. So Steve is going to be our presenter today. He's going to review the numerous types of RTK, explain how they function, and break down some of the major differences and similarities. And at the end of the presentation, we'll have a Q&A session. So any question you have for Steve, you can go to the bottom of your screen and see the little Q&A icon there. Pop that open, type your question, and I'll get that over to Steve. All right, Steve, without further ado, I'll hand it over to you. Take it away.
All right, great. Thanks for the introduction, Noah. Steve Riddle here with DigiFarm, and I'm going to try to go through all the different types of RTK and their offerings and share some of the similarities, differences, things that could affect accuracy, and a little bit on the reliability side. Seems like today that there's many guys, especially if they're strip tillers, you're running RTK already, and when I'm talking with growers at an event or a show, it seems like it's a lot of is I'm explaining what differences there are and maybe what they're using and differences that are available on the market. So we'll go ahead and get rolling here. So real-time kinematic, thus RTK, and basically this could have been 2 pages, but it's more or less a technique to increase the accuracy of the GPS signals with a fixed base sending corrections to a rover, which would be you and your GPS system in the field or wherever you're at with whatever you're doing there. And in a sense, what we're doing is we're ground referencing GPS data and correcting it at a closer distance to where you are in the field. And so just wanted to throw that out there. As Noah said, we're going to set some expectations for accuracy, review some options, and then I've got some other considerations. We'll go through a little list of some other factors to consider. So when I first heard the word RTK, and for quite some time, I think in my mind, every time I heard that, I just simply thought of sub-inch repeatable accuracy year after year. And what I learned at some point in time was that that's not necessarily true. So that's part of what we're going to talk about today. On the screenshot here is a picture of a display where the customer or the grower here is putting in field tile, and he's using auto steer on the tractor for the horizontal accuracy. And to the right there's a measurement icon there showing the vertical accuracy of the depth of the plow that they're putting in. I think if we look real close, maybe right now that tile pipe's going in at about 37 inches deep there. So there's horizontal accuracy and vertical accuracy, and we'll discuss that here. So the nice thing is about determining accuracy really for RTK is no matter who the provider is and what type of a system it is or technology being used, we all have the same rules that affect us for that accuracy. And there again, the calculations, we could fill a couple of pages of what all entails calculating that and to understand it. But basically, there's a distance rule, and I think everybody pretty well agrees as far as all the providers that simply put that every 10 miles from where you are in relationship to the nearest base station, you lose 1 inch of repeatable horizontal accuracy. So we're talking about repeatable and horizontal accuracy. So if you're at 5 miles in theory, at that moment, you could potentially be as half inch repeatable horizontal accuracy. Vertical control is a lot more difficult as far as how it's calculated and accuracies are determined, but the thing that I think everybody agrees upon that I've ever met is we've all agreed that you simply double your horizontal error to determine your vertical accuracy level. So that's real important to understand what, are we talking about horizontal, vertical, and throughout all this, one of the most important things, the takeaway today would be, if you didn't know already, at about 10 miles away from that base station under RTK, repeatable accuracy, you could be as, an inch off. Now, pass to pass may be, a tad bit better than that, and you're sitting there, looking at 0.0 accuracy or a whole lot less. But so that's there again, that's repeatable. First type of RTK I want to talk about is portable radio base. Most often, this is going to be marketed with a installation, say with a tile plow. You're putting a portable base in the field, probably within less than a mile of where you're at, where you're working. And I'm not going to argue by far that that's going to, should be the most accurate, as far as that distance goes. But what we run across is that's a line of sight restriction, that radio signal being broadcasted. So, any tree foliage, hills or the changing in the terrain, or buildings can disrupt that signal and make that, not receivable. The other thing is when you put up a portable base, just as other base stations, you do a survey process. The portable base can do what's called a quick survey, and you may be able to adjust the parameters for the accuracy. You're putting in a vertical, say a vertical installation. That can be a little concerning if you're allowing degraded accuracy, so the survey is quick. But if you're just doing it for a 1-day installation and there's no restrictions in the base and where you're going to be in the field, this works. You do need a remote power source. That's got to be taken care of. If you do have to move that, that adds to time consuming setting it up and moving, as opposed to being in the field and getting some work done. Where this really is difficult to work with, though, is if you're going to try to use it in a row crop farming applications and use it to repeat passes throughout the year. That's just hard to do. And maybe it's feasible in where you're at in the field sizes and what you're doing. But if you say strip till with this and want to come back and plant and use the portable base, that portable base has got to be exactly in the same spot that it was when you strip tilled. So even if you had a concrete post poured, freeze and thaw cycles, movement of that post, if it moves a half inch, all of a sudden you're half inch off right out of the gate. So that's hard to use for repeat passes in a grow season. And I did mention, though, the benefit there, though, is it does provide a really short baseline, for accuracy. Moving on, then, that same technology, radio RTK, probably the oldest out there for sure. Plenty of it still being utilized. There again, it's line of sight restricted with trees, hills, buildings. The survey process can be questionable for its accuracy. It's just 24 hours or less. This is the one that I find when guys are transitioning from a radio RTK over to a cellular based, especially a virtual base network or a virtual reference station network that we'll talk about later. And a lot of it's got to do just with the initial survey process. These receivers broadcasting the RTK corrections are mounted up on a tower or a grain leg. Sometimes they can have movement. And there again, they've got to have a remote power source as well. The other difficult thing is that each one has its own unique base identification number, and you have to manage which base was used with each field and application. So I think over time there's some that you still have to enter it at once, but you got to get it right, and then it geofences and uses it. But if you're between, if you're out there and you're between two different radio bases and you're about dead center in the middle, and you go to pick one and plant with it, but then you want to come back and side dress with the other, and get the wrong ID put in. There could be some big differences there. And there again, they could be even equal distance away, but it's really all about that survey process. But if a guy is with radio base switching to a different cellular service, I think I run across this one as the one that's the most likely to see larger line shifts and a lot of variations with it. This one is also, this type is because of being up on a grain lake or a tower, it's affected mostly by extreme weather and for sure lightning strikes. The problem then that occurs is if one radio base is down, others that maybe 16, 18, 20 miles away, you may not be able to pick that up and use that because of the line of sight restrictions. So now if you're blessed with farming in an area that's 6-8 mile radius from your home place, and maybe you're a host site or you've got a radio base and you don't have a lot of tree foliage, why, that happens too. So it does have its fit, and it, as long as everything's healthy and it's working, there's nothing wrong with this. There's just different options out there. So plenty of radio still happening today, I'm sure. So now we're going to get into the cellular RTK, and first I want to talk about a single base cellular RTK corrections. Similar to radio in the fact that base station that's out there, there may be a whole, what somebody's calling a whole network of them, but it's kind of like radio. One base station doesn't know that the other exists. So, it's really not is it a network, or is it just a bunch of them out there? Single base cellular RTK would represent what most states have as what they call a Coors network. And there are other private available paid for offerings through other RTK providers. And the other thing here is that not all states have a Coors network. And Coors, CORS, stands for Constant Operating Reference Station. The state-owned ones are primarily, their purpose and function is to facilitate the state entities of highway, road people and government agencies that need that correction service. And some states, for no charge, you have to inquire with them, or for a minimal fee, will let you access their network and their signals. There again, these are typically a survey process, maybe of 24 hours or less. Kind of challenging that process for overall accuracy. And then if you look at a base coverage map for providers like this, their map will show 30-mile radiuses, and most all of us providers do. But you got to remember that distance rule. Their map's showing 30 miles, but you got to remember that 10-mile range. So if you're looking for repeatable accuracy, I would challenge using this, and it's certainly vertical. You wouldn't want to trust that much more than a few miles outside where that physical base is. You also might have to change a base ID information if you travel beyond the range of one of these base stations also. And if one base goes down, also like radio RTK, now here you could probably pick up that signal from that other nearest base station, because cellular is not restricted by line of sight. But what you got to remember is that what does that baseline distance look like now? There again, if you're doing pass to pass, maybe it's okay. But if you're trying to do repeatable accuracy, that's where that's going to come up and eventually show the issues. If it's a state Coors network, it kind of depends on their downtime. If they've got doing just simply updates, or they've got server problems and things are offline, it's their discretion as to when do they get back up and running. And a lot of them are limited to the brands of the GPS that they support also. But that single base cellular RTK, it's plenty of it out there, but there again, if you're just looking for pass to pass accuracy and knowing where those physical bases are, maybe that's okay. And like I said, it does get away from the hindering of line of sight. So VBN and VRS cellular RTK similarities to single base, not line of sight restricted. It's not tower grain leg mounted, typically, as in the pictures here. A two-story height, good secure building mount, and a clear view of the sky. So we break down those problems. There's also, just like a single base cellular, there's going to be a GPS unit there at the base station, and then through a receiver router setup plugged into a good reliable internet connection, that's going to communicate with that RTK signal provider's server, same as cellular, and we'll get into how that flows and how that works. And there again, single or VBN or VRS networks, that cellular signal is sent from the provider's server to you in the field in the form of a cellular data packet. So that's like what a text message is sent, and it's stronger than voice. So that's a good thing. But those are all similarities of the single base and a VBN or virtual base or VRS cellular RTK. So VBN and VRS, VBN, virtual base network, often also called VRS, virtual reference stations. So they're each using physical base stations like a single base solution, but they take that to a next level through the software in their offering. In this picture here, you'll see a Fendt tractor and the controller for a drone as examples, say, that would be in the field. And they've been powered up and starting a session. So what happens here is, obviously we're still looking at GPS satellite data, but now versus single base, what the virtual base or a virtual reference station network does, they'll see a GGA start up and initiate a session, and the provider will see that in relationship to the nearest 3 or multiple base stations, not just one. And through their software, they'll triangulate that position and create a virtual base. In this case, in the picture, it's shown by a red T. Now, I know our company and others, that virtual base by intent is positioned closer to where that device is than where the physical base stations are. And it's all because of that baseline to rover distance. So I know in some cases that virtual base could be created as close as 3 miles. So then when you go back and start talking about what accuracy level did that just create, it's if you're at, remember that 10-mile rule, repeatability should be about 1 inch. Well, if I'm at 3/10 or 3 miles, in theory, that should be 3/10. I know when I see a base station at 3 miles, the safe answer for me is half inch or better horizontal repeatability. Kind of jumped ahead, but this is kind of a recap of that. Let's see here. So these base stations are surveyed in for a much longer period of time because of the triangulation that has to take place. So that's a big difference in a virtual base network or a virtual reference station network, is that lengthy survey process. I would say in this case, where a single base cellular or radio base, it's there, it knows where it's at, but it doesn't know where any others exist. Where here in a virtual base network or a virtual reference station setup, it's like each base station knows where the other one is, because they're using to communicate to create that virtual base. There does need to be a minimum number of base stations in a cluster in order to create this. So I think the general rule is if there's 5, they can't be just in a straight line. They've got to be in somewhat of a cluster to be able to triangulate. If you can just look at a physical map where a provider has their base stations that are VBN or virtual or VRS, if you can draw yourself in a triangle of 3 base stations that are touching or overlapping, just think of it that way, as that's when the capability occurs that can take place and be done. So the other benefit here is not only that close baseline distance from where the virtual base is, or the virtual reference station to the rover, but if a physical base station in this setup here would happen to be offline, typically then data from another physical base further out can be used, and it's kind of like a self-healing network or a band-aid. They can still create that virtual base, and typically to the naked eye, nobody knows anything ever happened, temporarily. The other thing that with a virtual base, I know some providers can. So it's created at 3 miles when a session is initiated. Now, if you complete a field and take off and drive to the next field and you don't cycle power on your GPS system, that distance will continue to grow. Well, I guess we don't know which direction you're going to travel, but you could be even driving closer to it. But if you are driving further from it, I know there's situations where it will reset on the fly before it reaches that 10-mile range. I want to say around 7 miles, and there isn't any line shift that occurs. And we got to go back to the fact that the survey process and how these base stations all more or less communicate with each other and create that new virtual base. So it still maintains that close distance, less than that 10-mile range for sure, which is a good thing. So the key points here would be foremost would be to remember that distance rule. Beyond 10 miles, and it's affecting your repeatability. If you're strip tilling, that's huge. All the displays that I've ever ran across when they're unlocked for RTK, somewhere in that programming in your display in the tools menu, it'll show a baseline distance reading. So you can always go check that. And if you're not sure, if you're running the system you're running, if it's a virtual base or virtual reference station provider or just single, just go look at this baseline distance reading, because if it's 10, 12 miles, or that's going to give you a clue there. And always remember, double your horizontal error, and that'll calculate what your vertical error should be. There again, not all single cellular single base, and cellular in general, I think, especially the single base ones I've found may not necessarily work, especially your state ones may not work with all your various brands of GPS unit out there. Another one that we've heard a lot about, and in the offerings from different GPS companies and stuff, is satellite RTK, or RTK from the sky. I think a lot of that's still fairly new or newer. There's obviously guys who are using it, but here I would make sure that you've communicated with the provider and read and be confident that, what about the repeatability and then timeline also? Is this just for pass to pass? Is it a limited time? Is it in season? 9 months? What kind of time limitations are there? They're utilizing additional L-band satellite corrections, so that there's just more averaging that can take place, I think, on most of these. But there's no ground reference station, and so that's what's kind of intriguing but puzzling also. Like I said, just make sure you're getting the right information, and especially if you need repeatability, and it doesn't matter if it's within 24 hours or 4 months. If you're putting strips in the fall and then want to plant and then go back side dress and stuff, you need that year to year and everything there. So the other thing is base station installations and hardware used. Certainly can be a factor in any of the providers. I think for accuracy and reliability, there's antennas out there that meet survey grade spec. Uh, they're typically larger. We'll often think is better, but there's things about those with ionic atmospheric choke rings. They typically are very particular with the mounting, and have a leveling ring so that unit can be perfectly level. There's typically a directional arrow that's got to be just spot on, due north, and there's others that are not. So that's a big variation. And hardware used to deliver the corrections, I think this is more about reliability, and it's not really about accuracy here, but you're gonna question, what's down, what's wrong, what's not working. So radio RTK, there's 900 versus 450 radios. Obviously, the 450 megahertz radio is a lot stronger signal. It can burn through some tree foliage. So there's differences there. Same thing with cellular modems. Cellular modems typically have one or two external mounted, what we call high dB gain cell antennas. If they're using just a little stick antenna, that's not going to have as good a performance picking up that the high dB gain external cell antennas. With cellular, you also get Bluetooth devices, a beacon, or some folks call it a dongle. So it's paired to an iPad or a cell phone, and there where it really comes into play is the differences of cell phone internal antenna versus an iPad. I've seen plenty of times my iPad is working fine, but my phone isn't because I'm in a really weak, questionable cell area, and we're trying to stream a correction data. So I know an iPad is the preferred device. And a lot of it because just the fact that internal antenna is so much stronger and bigger than what your cell phone is. Especially if you're on the fringe of the strength of the cell network. And there again, whether it's a modem device or a Bluetooth piece and an iPad, iPhone, we're sending a correction signal. Everybody is in cellular that's in the form of a data packet. So kind of my rule of thumb is asking, in your worst area, your worst field, where you constantly drop calls or can't make a call, can you send a text without it failing to send? Because if it'll send all the time and never fail to send, whether you're going to use a modem or a Bluetooth piece and an iPad, we should be okay with what we need to do. I don't think I have a slide on here, but I did want to mention the other difference in GPS systems out there when it comes to receiving a cellular correction signal or a radio signal for that matter. Make sure you know and understand, especially if you're shopping for new, what are the fallbacks? If a correction signal is not seen and more than 1 minute goes by, ask that question: what happens? There are GPS receivers out there that will go into an extend mode, anywhere from 15 minutes to beyond 24 hours. There's exfil that has some of that capability for about 15 minutes with a couple different providers, John Deere and Case Trimble there. no-till, there's what's called glide, and it's more of a smooth transition from RTK back to WAS. But know those time factors and what the capabilities and the settings are, and take advantage of those. So in a cellular RTK corrections or a radio, if you get behind a tree row or something, and maybe that'll give you time to pop back out or get into a back down the field a little bit, back into a cellular coverage where your receiver sees another correction signal. So that's something to be aware of also. Another topic, this comes up more and more all the time. I think people are more educated about it or hear about it and are asking about it. And it's, what is a datum? And so NAD83, North American datum, 1983. And there are newer updates to this, and even some newer solutions or coming out. But it's a benchmark protocol for all the GPS systems. They say in North America, but I don't believe it's used in Mexico, but U.S. and Canada. And it's everybody but John Deere on this, which is going to change or is changing. But it's a benchmark protocol. Let's say there's 200 master reference survey pins across the U.S. and Canada, and everything originates to or from that, as far as when and it's for all industries. So when a surveyor is out and he's marking it could be a personal property or a fence line for a house. It doesn't even have to necessarily be in the field or whatever for something, but that all chases back to these master reference points, this benchmark reference points. And so everybody, with the exception of John Deere, uses that protocol for their GPS world. I would think lat long positions would be lat long positions, but this is that protocol, and it's been in use, and it's changed and improved, but clear back into the early 1900s. And maybe this is why when out in the Wild West, two railroad companies wouldn't meet in the middle when they each took part in joining somewhere with a railroad system. But it's so it's whether it's Trimble, no-till, which is Ag Leader and Raven, or Topcon or Hemisphere GPS manufacturers, they're all using NAD83 as a benchmark, and up until recent, John Deere has always been using a separate one, which is ITRF, and it's an international datum, and it's a single reference point that is like as if they've calculated the center, or this ITRF has calculated the center core of the Earth, and then it's a worldwide reference point, and it's a single point. And what is changing, I'd mentioned, is John Deere with their SF RTK now. There again, it's new enough, it's satellite based RTK. There is a time limit on it, so I'd say for now, watching, learning, and doing homework is the best on it. But that is using NAD83, where previous, all of John Deere with their radio and mobile RTK, they did a little bit of a fair number of years back, was all using the ITRF. So now the next thing here is sharing of guidance lines, and this is especially when you're talking about somebody with a no-till or Trimble receiver, and then you have a John Deere receiver. And I just had this conversation 2 days ago. A grower, big farm, and they've got a mixed fleet, and they just know that when they go to share guidance lines, one to the other, when they load them, they're about, it varies, I hear 28 to 30 inches, but it's typically around that 30-inch mark that they're off, and it's because of these different datums. Now, to my knowledge, there are a couple software tool providers that can convert guidance lines. I know specific with DigiFarm, we can address this issue. It's a manual process when we first set up an end user, but we can manipulate some datums and user tied to a username and stuff. So it would be dependent upon your provider of RTK and possibly your GPS provider. How and can they address these two different datums? And if I'm not mistaken, I believe John Deere is working on a tool also, because we'll need to do that with SFRTK running NAD83, and I'm sure, and they've got plenty of guys still running radio RTK. So there could be times where they certainly are going to need that. But so that's what a datum is. It's important to understand, and especially if you're going to get into a mixed fleet or potentially could. The other next thing here, using multiple RTK providers, we're migrating from one provider to another. I kind of touched on this maybe a little real early on, and it's really about, I got to go back to that survey process, and the shorter the survey, and typically the more error that could be. If you were running radio RTK and you were running under, say, 3 base stations, and you've got multiple fields, and you switch and go to a cellular RTK provider, especially if it was a VRS network or a VBN network where they've been surveyed in, a little tighter, in my opinion, you could go with your existing guidance lines from radio and go to one base and not see any noticeable error. You could go to another one and maybe be 6 inches off. And if you're going to be 6 inches off in one field under that base ID, you're probably going to be 6 inches off all those fields under that base ID in the migration. And you go to the third one, and maybe it's, who knows what, it's 2 inches or it's 2 feet. And there again, it would be all those fields under that base ID, and we got to go back to that survey process. Another thing that keeps coming up here more and more all the time, new correction satellites. So besides GPS, been using GLONASS, which is a Russian basically they're additional correction satellites available that our GPS receivers can see, or GPS antennas and receivers. So GLONASS has been out for quite a while, and it's a Russian-based correction satellites. They're again just adding to the number of satellites for correction data to hone in on better accuracy of just a basic GPS signal. And then there's Beidou and Galileo, which are recently new. Beidou being Chinese correction satellites, and Galileo is out of some of the European world area, network area, and it's all good because you're firing up new GPS units. And I hear guys, and I see, in the field, I see, oh my God, this GPS antenna, my old one used to only pick up 12 satellites, and this one's seeing 28 or 30, and that's just awesome. Well, with RTK, what you've got to also know, and realize is, what is that RTK provider? What are they using at their base station levels? Because you may see that many, but they may not be being utilized in the RTK correction process. And I believe I'd heard, but I can't remember which brand, but I thought recently I'd heard of a brand of a GPS that was saying, okay, we see all these, but here's the ones that are being used. So I know, in particular, our company is in process of updating a bunch of old base stations through software and hardware to here real soon be able to utilize all those. Right now it's kind of sporadic, but so that's important to know and understand. Your receiver sees them, but are they being utilized with the correction signal as well? Another one here, every day there's something new. New GPS systems offering here in the U.S. that are from overseas markets for RTK, and you're going to see a display and a electrical mechanical drive auto steer system to go or replace on the steering wheel, and they're just a dirt cheap price, and they're RTK unlocked, and you're like, ooh, what's up with this? And those typically all have a internal modem device in their display, and they simply say, oh, just put a SIM card in, and you can program all the cellular RTK providers credentials and access their signal right to the display. And what I'm finding is most of them you cannot, because they won't accept a U.S. SIM card with a U.S. carrier. But however, you can tether them to a hotspot source and then make them work in that manner. So you're just tethering it to a hotspot, and then you can program through the in-trip settings. Now, what I've run across is most all of these are talking an identical language or want to see a correction format under RTCM3, and which if you have multiple RTCM3 mount points, or the language that we talk, it's the one that would be like for a newer Trimble system or a Trimble 372. They all talk that same language, so I've not been dead in the water. There's actually quite a few of these out here. So FJ Dynamics, Agris, there's an Agra GPS unit out of Canada. Field B is another one. It's an app-based solution. There's a Field Level and Field Guide. That's another app-based solution. And so, really, when you're looking at these, if I were to ask you, what you've got there is does it have a built-in modem device, or what we call in-trip settings, and then what language or what mount point do they talk? And so that's as I say, just do the homework on them, and we can be a part of that also, or your provider can. But they got to be typically cellular RTK corrections. And kind of nearing the end here. Cellular RTK via in-trip is the most common and progressive path to RTK today. So in-trip is a protocol where there's every cellular, whether it's single cell based or a VBN or VRS setup, basically either in a modem device or in a display or in a unit, there's a place where we can program in. Each provider of cellular RTK has a unique identifier that's there's a host server number and a port number. Those are specific to each provider. And then you're given a username and password credential, and then you have to enter in or select the language that GPS unit talks. Now, today, what we're finding, every drone that's out there has that built into their controller. They're actually super easy to provide RTK to. Some of your displays out there, an Ag Leader in Command, it has that built into the display. And then a lot of OEMs today have a modem device in the tractor already, and they're using it for or in a sprayer unit. They're using that modem for telematics, remote support. You can use it for various file transfers and APIs with other softwares, but they all, with the exception of one, have an open source, what we call in-trip, into that modem that's factory installed, that can be used rather than being redundant in the hardware. We don't, a lot of times today, we don't need to add another piece of hardware to be able to deliver the RTK corrections. And expect anything that you're looking at that's autonomous or robotic, expect that they're going to want you, or it's only going to operate with RTK. That just makes sense too. So, no, I think I've got through the bulk of everything I could thought of during putting my presentation together there. So
that's a lot of information there. 43 minutes of jam-packed information. So we do have some time for some questions for Steve here. If you want to get your questions in now, Q&A icon bottom of your screen, type whatever question you have and I'll get to it. But I'll get it started here, Steve. So what can you tell us about RTK as it relates to implement steer? So RTK and implement steer.
Yeah, thanks for that one. That easier said than done. There we go. Question answered. That's one that we touch often. There's two types of implement steer out there, and so if you're putting strips in the fall or even pre-plant spring and want to come back and plant, you might think you're on good level ground and you don't need it, but there can be differences in soil types, and and the bigger the bar, the more maybe the more you're running across, and the way the implements drift or their natural movement, which way are they going to shift on their own, and in different wheel tracks or hard pans or soil type changes in the field or something like that. So you don't necessarily have to have a lot of big rolling hills and stuff to need implement steer. Two types implement steer, both require a GPS unit on the tractor and one on the implement itself. I think there's I'm just going to say it, there's too many guys using passive implement steer. It's the least cost and the easiest to do, but it's moving the tractor where it needs. So the implement is where it needs to be. So if the implement needs shifted over, 3-4 inches, whatever that is, or 16 inches, it'll move the tractor over until that implement lines up. What I've seen happen and uh, firsthand is on a fairly aggressive hill is the front duals on a row crop tractor will migrate up the hill so far that they actually get sucked into the next set of strips, and then it becomes difficult to get that out of there, and the strip till bar, the planter kind of hangs back there off until the steering kind of finally gets enough oomph to get out of it. But if you set it aggressive enough, then in normal operation it's too chattery, and it's there's a lot of fine tune adjustments on your settings for both those steering systems to get that to work and work properly. The active implement steer is definitely more rewarding, I think, as far as its performance. And you've either got a side shifter that's moving the implement separately, so the tractor's on its line, and then the implement is being physically steered with a hitch. And then the other one that also works well is a coulter system. So there's big aggressive coulters, however many are needed and recommended by the provider of that, where it's physically back there, coulters in the ground, steering the implement itself, physically in there. So, but yeah, that's going to come up. If you're looking to get into strip till or wrestling with that right now, that one needs homework.
All right, I wanted to ask you about drones as well. I know the strip tiller in Georgia, Alex Harrell, who broke the soybean yield record, he told me about how he used drones during the season to kind of keep his crops pumped up. When the weather was bad, he was still able to do everything he wanted with the drones. Is drones and RTK, what's the relationship there? Is that an easy process or?
Yeah, super easy actually. I get a fair number of calls each week, and plenty of guys at trade shows coming up, and they're with hesitation in their voice. It's I'm going to ask. I don't know if you've done this or this can be done, but I've read my drone can run RTK, and it's and at some point in time you quit counting. I know our company we've done a lot of them. And so in that controller specifically, they're all pretty well the same. In the controller itself, there's most of them will refer to it somehow as a custom RTK network settings, and then you'll program in the same thing in what we program into modems or our other modem devices and display. Excuse me, and displays, and there's a place I'll call it like an in-trip host number, a port number. Those are unique identifiers to that provider's service. Enter in a username and password, and then a mount point, that language it wants to talk. And then you tether that to a hotspot, and so now we're streaming the correction data actually to the drone controller itself. Then the drone controller pushes it out to the drone, because a lot of guys are asking, well, my drone's going to be this far away from the controller, but they handle it and handle that a long distance. I'll say this also. I like to give some good pointers out there. Guys that are running cellular RTK already, no matter really who your provider is, it's all about managing typically how their pricing models work. It's all about managing how many need to run at the same time. So my typical customer I'm talking to at a farm show or an event, maybe he's got 2 RTK cellular subscriptions with a provider, and maybe he's running the strip till bar and the planter, and they get done with the strip till bar, then it's the planter and the sprayer, and eventually the planter's done, and then they're out running the big sprayer. Well, come time for fungicides, they might still be running the sprayer, but they've got one set of credentials they're not using, and they can use those credentials to enter into the drone and actually are getting by without having to potentially purchase another subscription. And so, hey, that's like I said, I like to sell subscriptions, but a lot of times they've already got enough, and I'm just helping manage what they got. But it's easy.
All right, we have a question here now. Will DigiFarm be able to do file transfer? He says he utilizes the Elevate for RTK correction on a Trimble FMX. So would that be possible to send files directly to his Agfinity account?
No, that would not. It's on a wish list. There's no timeline on it right now, but an Elevate Slim modem is just a modem device. There's no additional. Now, if he's running an ag leader and it's an ag leader in command, that actually can be tackled with that Elevate Slim needs a hotspot source is what it needs, and so then you could through if it's an in command display, but there's a lot of redundancy in file transfers and stuff right now, and I don't know that we'll get to that point. We've got a few other things to probably ahead of that on that list. That capability exists already through his Agfinity account, and he would really just need a hotspot source.
All right, we have time for a few more questions. If you have any right now, would be the time to get them in. And just a reminder, today's session is being recorded. So what we'll do is we'll send you an email when the recording is posted to our website, strip-tillfarmer.com, and also our No-Till Farmer YouTube page. So if you want to go back and rewatch or share this with anyone, you'll be able to do so. Steve, what about growers outside of a coverage area? What happens in that situation?
That's I'm assuming they're going to be talking with some private. Coors networks are typically in a state, and they're state entities, and they're probably either got the whole state done or just the parts that they want. But if you're working with a independent, private provider of RTK corrections, I would contact them. Cellular RTK is a little trickier because it's going to involve a server and software, and you're just not going to go out and buy your own base station. So I would get a hold of the provider of that RTK corrections, or a local dealer, and start asking those questions. I know of one, if there's enough opportunity for new business, that will go in and put up a base station and facilitate that coverage, but the conversations have to get started, and it's just got to. Anytime that question comes in that I need to know, what's an address and a radius. What area does that grower travel, or that ag retailer? What area do they need covered, and what are we talking about is it a single unit or multiple units? Is it, what's the short-term, long-term potential? And but that location is key also. And then cellular needs base stations. We're not up on a grain leg or a tower, so we need a good solid building structure, a good clear view of the sky, and a reliable internet source to plug into. And so it's and those are the starting points to that conversation.
All right, well, it looks like we don't have any more questions at the moment. So, Steve, we can go ahead and wrap things up. I'll give you a final word. Anything else you want to add before we wrap things up here?
No, I appreciate the opportunity. We appreciate working with Lester Media, the Precision Farming Dealers Summit, and all the strip-till and no-till conferences you guys provide, and it's all good stuff.
Yeah, well, thanks for taking the time. I know, as we were talking about before we went on air here, it's been a busy summer for you. You've been traveling almost every week, right?
Pretty much. Yep, pretty much.
All right, well, great presentation. Again, another reminder, this will be recorded and posted on the No-Till Farmer YouTube page and strip-tillfarmer.com. If you registered for this webinar, which you did because you're watching it now, we'll give you an email. So keep an eye out in the inbox there for the recording. In the meantime, if you have any ideas for any other topics you'd like to see us covered in the webinars, you could shoot me an email at nnewman@lessitermedia.com. And I know it's a busy time of year, so thank you everyone for tuning in today. And on behalf of Strip-Till Farmer and DigiFarm and Steve Riddle, sorry about that.
What's that?
Thanks so much for tuning in, and hey, we hope to see you again soon. Have a great day.